last session that we went through inequalities and we established a recipe. We went through looking at the basic recipe for it, and there was a few little gaps that we now need to fill in as they get a little more, not difficult, but something that we've got to remember. Let us take one example like this, shall we? 8 minus 2x. Okay, 8 minus 2x, and less than or equal to 0. X is an element of z. Right. Now, what do? We treat it straightforward like any other equation. Pretend that that's an equal to. Okay, so therefore we take the 8 over. We here minus 2x less than or equal to minus 8 because that becomes a negative. Now we're going to divide through by minus 2, right? Because that is going to give us, at the bottom, it's going to give us x, and over there it's going to, just put in the minus sign over there, it's going to give us a 4. The thing that you've got to remember here is when you divide by a minus, the sign flips. All right? So if we divide or times by a negative, change direction of sign. Okay, very critical. If we divide or we multiply by a negative number, we flip the sign around. Okay, that's what we do with these. Okay, let's have a look at a couple of examples here. All right, let's say we've got this 3 times x minus 2 less than 6 times x plus 1, and x is an element of R. Okay, step 1, remember, treat as usual. So how would we do this in the normal scenario? We would multiply the brackets out and group like terms. 3x minus 6 less than 6x plus 6, right? Then we would take the 6 to the other side, and we would take that 6 to the other side. So we would have 3x minus 6x, and we would have plus 6 plus 6. Do we switch the sign around? No, because we didn't divide or times by a negative number. We merely took the over to the other side. That doesn't mean that we change signs. Only division or multiplication by a negative sign does that. So the sign stays the same. Then we end up with minus 3x less than or equal to 12. Right? And from there, once again, what are we going to do? We're going to be dividing through by minus 3. Which means over this side we're going to get x, and over here we're going to get minus 4. And what do we have to do? Switch the sign around. Okay? And we switch the sign around, x greater than minus 4. Now, how do we plot it? Let's have a look. What did we say we do? We first look at the outer boundaries, because we're going to see 2 boundaries coming up soon. Okay? Over here, we say we've got minus 4. So we know we're starting at minus 4, minus 3, minus 2. Let's put in a 0. Let's put in a minus 5 because we don't know which way we're going. We're starting at minus 4, so we are here. Then we look. Have we got an equal? Can it be solid? It's empty underneath, right? Can you see here? It's empty. Empty underneath the sign. So that means it's an empty dot. Then I go with my pencil and I say, which way are you going? X must be greater than u. Then I look and I see it's all numbers, which means it's a straight line up like that. Okay, right. Let's have a look at another one. This one over here is 3x minus 1, 3x minus 1 over 2, minus 3 minus x over 3 less than x over 12, okay, plus 2, and they say x is an element of integers, z. Right, well, treat as usual. Okay. What do? Well, first of all, we say, okay, times by the LCD, correct? Because you want to get rid of fractions. Of course, you can take the x over 12 to the other side if you wish, and do it like the problems where we take everything to the other side and then have a big LCD and then multiply through. You can do that, or you can just get rid of the LCD. The reason being here, the LCD is just numbers. Generally, we do the other approach, that big long thing with a complicated LCD when we've got x underneath. Okay, so the LCD here is going to be 12, right? So what do? Remember one of the basics that we said. Go and do each one. Why? Because the chances are that we will forget if we don't. It's only human to forget. So then we can do our cross-cancelling. 2 goes in there, 6. So we end up with 6 times 3x minus 1. 3 goes into the 12 over here. 4 times 3 minus x. Less than or equal to the 12 cancels out totally, leaving with x plus 24. Okay? Therefore, we've now got, we remove the brackets. Okay? We've gotten rid of the denominator. Let's remove the brackets. So we end up with 18x minus 6 minus 12 plus 4x. There's the plus, right? Less than x plus 24. Let's move the x to the other side and get everything to that. So we've got 18x plus 4x minus x less than or equal to 24 plus 6 plus 12. That leaves us with 21x less than or equal to, add that up to 42. And last of all, we end up with, let's just get another line there. Okay, we said we had over here, we had 21x less than 42. We then end up with x less than 2. How do we do it? Well, we look at our number line and we say, I've got a 2. I'll put a 3 and a 4. I'll put a 1 and a 0 and a minus 1. I go, can x be 2? No, it's empty, so it's a hollow dot, right? Then I say, okay, now we look at our domain. What's our domain? So our domain said x an element of z, integers. So I color in and it's going that way because x must be less than. Can you see? And how do I indicate it continues? I put a line up like that. Okay, that's a straightforward example there. Okay. Let's take this one over here now, all right? Right. Okay. Right. Okay. Let's have a look at the next one. The next one is a half. Okay. Go down to page 2. Let's have a look at the next one. The next one says a half is greater than x over 6 plus 2 over 3. Okay. Which is greater than 7 over 3. X an element of real numbers. Okay, now hold on. Can you see over here what we've got here? We've got a double sign. Okay. What I will do is I will put those in red when I can get it like that. We've got a double equation, right? Now, how do we handle these? Well, the first thing that you do is you say, okay, the first thing you do is you split. Make them into 2 separate equations. So you say that's a half greater than x over 6 plus 2 over 3. And this one is x over 6 plus 2 over 3 greater than 7 over 3. Can you see what I've done? I've split them into 2. The reason why, yes, you can do them in 1. It, however, gets a bit confusing if the LCDs are not the same on each side. You're going to be multiplying through by unnecessary LCD. The other side of it is that it can become a bit tricky when you're doing minuses. Okay? If you split them into 2 equations, you deal with one, finish it, then you deal with the next, and finish it, then you put them back together again on the number line. Okay? And that's the safest way. It avoids a lot of confusion in my mind. So therefore, what am I going to do over here? I have to multiply through on this side by a 3, don't I? Or a 6. I've got to go through by a 6. Right, like so. That then says I can cross cancel, and I'm going to land up with 3 greater than x plus 4. Therefore, I go this way and I say minus 1 greater than or equal to x. Okay? And on this side, I'm going to multiply through by what? Okay? Multiply by 6, 6, and 6. And we end up with the following. We end up with x plus 4 must be greater than 14. So therefore, x must be greater than 14 minus 4, which is 10. And then I can put them back together again. Can you see? The x and the x goes back. I just basically put them together. Right? Now, let's look at the number line for this. Okay? Now, we say, right. Okay, first of all, let's draw a number line. We look at the outer boundaries. I've got a 10 and a minus 1. Okay, let's put in a 0 and a minus 2 and a 9 and an 11 on either side, like so, right? Now, first of all, go to the boundary, treat them separately again. Okay, let's look at this one. Minus 1, okay, it can be, okay, it's full underneath the sign, so at minus 1, I've got a that. And it tells me x must be that way. And real, so it's a line like that, isn't it? Then I go to the 10 and I say, it's empty underneath, therefore it's an empty dot, and x must be greater than 10. Because it's real, I would have put my little line up there, just my little check line. Okay. So if you've got them as splits, okay, if you've got them rather as 2 separate ones, how do we do it? We go straight forward and split them, okay, and put them back together at the end. Let's look at another example, okay, shall we? Minus 2x plus 5, let's have a look here. Minus 2x plus 5 less than or equal to x minus 5 less than 3x plus 15. X an element of real numbers, right? So we know our arrows are going to be from the dots out. So let's say, what do? We split. Split and treat them as separate equations. So let's look, minus 2x, sorry, that's actually a 7. My apologies for that. I actually must change it in my notes here while I remember, because, okay, right, so let us split. So I've got minus 2x plus 7 less than or equal to x minus 5, okay? That is then going to be the minus 2x minus x less than or equal to minus 5 minus 7, correct? Therefore, that's going to be minus 3x less than or equal to minus 12. Therefore, x must be, and what am I going to do now? Yes, I'm going to split that. Sorry, it's not split it. I'm going to flip it. And it must be equal to minus 12, 4. Okay, let me just tidy that up a little bit. Okay, this is minus 12 there, correct? Can you see the others where I took the minus signs over? If I'm adding or subtracting, it's fine. The sign stays. If I multiply or divide by a negative, the sign flips. Okay, let's take the next one down, and we write it down. We say x minus 5 less than 3x plus 15, and we then say that's x minus 3x less than or equal to 20. X minus 3x is minus 2x less than or equal to 20. X, and what am I going to do again? Because I'm dividing by minus 2. Therefore, I flip the sign around and, whoops, get it to black, and that's going to be 10. Okay, now what do? We go to our number line and we say, okay, let's draw you. Okay, look at my outer boundaries. Here they are, right? 4 and 10. So let's put in a 4 and a 10. 4 over here, 10 over here. Let's start with the 4. It's full underneath, so it's a solid dot, right? And what do? I say the arrow's going that way, greater than, so I pencil it in. X must be greater than, it's a hollow dot at 10, right? So what? And I'm going that way. Can you see the arrows are both pointing that way? Well, now I go and I say, okay, real numbers, like so and like so, right? Which means that anything greater than 4, but not 10, okay? Can you see you get different versions of these, right? Okay. So don't doubt yourself on the number line, okay? It's not impossible for it to look a little bit odd. Let's try another example. I hope you're doing these with me. 3x plus 5 greater than 5 minus x less than minus 8x plus 19. And this one they say x an element of integers. Okay, what do? First thing, it's a double, so we split apart. Okay, treat them as separates. 3x plus 5 greater than 5 minus x. Okay, and now let's take it to pieces. Take that over. 3x plus x less than, greater than, equal to 5 minus 5. Therefore, 4x greater than 0. Therefore, x greater than 0. This side, 5 minus x less than minus 8x plus 19. Let's take the x's over and take this. This becomes 9x minus x, doesn't it? Less than or equal to 19 minus 5. Okay? Yes. Okay. Not 9, 8. Sorry, I've already added it in my head. 8. So that's going to be plus 8x. So that's going to be 7x less than or equal to 14. X less than 2. Okay. I know sometimes I do say less than or equal to, right? That's just habit. So now what have we got here? We've got this. Let's now go to our number line and put it in. We've got a 0, a 1, a 2, a 3, and a minus 1. Let's look at the 0 side first. Okay, it's empty underneath, so it means it's a hollow dot. And the 2 is empty underneath. Okay, let me put in my little, it must go that way. And this one is less than 2, so it must be that way. And finally, it's integers only, which means it's only, that's the answer. It's only 1. That's the only integer that's going to be able to solve that equation, right? So all of these essentially, okay, is the same process that we're going to follow, right? Let us do one more of these. Oops. It didn't obey my command. Okay. Let's do one more. Okay, shall we? 3 over 2x. Okay. Let's just do this one. Yes. 3 over 2x minus 5 greater than x plus 2, which must be greater than or equal to 3x plus 6. Okay? What am I going to do? I'm going to split. Okay? I am going to split them into 2. Like so. Right? And I'm going to say 3 over 2x minus 5 like that, greater than x plus 2, and x plus 2 greater than or equal to 3x plus 6. Then I'm going to wiggle them around, and I'm going to eventually, this side here I must multiply through by 2, right? Because that's the LCD, isn't it? So I go 2 times 2 times 2 times 2, right? I know I say it a lot, but don't forget that step. 10 greater than or equal to 2x plus 4. Now we simplify. That's going to be 3x minus 2x greater than or equal to 10 plus 4. And what have I got? I've got x greater than 14. Looking on the other side, x plus 2. Now I've got nothing in the denominator. I don't have to multiply through. Please remember the LCD on your left-hand split. When you split it, that LCD and the right-hand side LCD, here they're not the same. I had to multiply through on the one side. On the other side, I don't. So don't worry if you have a situation like that. X minus 3x greater than or equal to 6 minus 2, right? Which means minus 2x, whoops, I'm getting a step ahead of myself now, greater than or equal to 4, right? Therefore, now I'm dividing by minus 2. Let's just put it in to remind ourselves. Okay, what must I do? It must go that way. So let's put that back to black, and that's a minus 2. All right, minus 2. Okay, so what do I do? Look at the boundaries here now, right? Look at the boundaries. Let's plot this, shall we? Okay, let's plot it. Okay. Well, what I didn't tell you is that x element of real numbers. Okay, right, let's look at my boundaries. On the one side, we've got 14, so let's put in 15 and 13. And on this side, we've got minus 2, so let's put in minus 3 and minus 1. And just for good measure, put 0 in over there. Okay? Everybody's got their individual likes and dislikes for these, but let's put it that way. Right, let's go to 14. It's empty underneath, so it's a hollow dot, right? And it's greater than, so my little arrow to myself means I'm going that direction. The next one is less than or equal to minus 2, which means it's a solid dot. And which way am I going? X must be less than. So I'm going to go this way. And then I look and it's real numbers, which means my arrow goes from the center out that way. All right? That is how you do inequalities, right? The next session I'm going to do is going to be, we're going to do trigonometry. But what do we do with inequalities? Let's recap. First of all, we say, okay, if it's a double inequality, we split. Work down the left-hand side and the right-hand side separately first, okay? Remember, what's the key to remember? If you are going to divide or multiply by a minus sign, you flip the inequality around, okay? You treat it as normal until that point. At the bottom of it, you recombine. That's your inequality, should you so wish to do so. How do we represent it on the number line? Simple. You go to what you got on the left-hand side and the right-hand side. If there aren't two sides, you just look at what your boundary is, okay? In the previous case, it was minus 2 and 14. You draw a number line to make sure that you've got this one and that one represented. I always put 1 or 2 each side, okay? Just because I think that sort of tells me if it's integers, I can go and fill it in, okay? Then I look and I say, okay, which way is x? Is x less than or greater than? I make a little mark at the top of at the top over here. So it was these, remember? Let's just put this in. I put that in and I put that in, which showed me which way I'm going to be counting. The last thing is I look, it's an element of R, real numbers, which means it's a solid arrow going away because it can be fractions, okay? Hopefully that's inequality sorted. They really aren't difficult. You always get one. They're always good marks. You guys should easily get 100% for it after the 2 sessions we've been together. Enjoy them. They're really not difficult. Next year you do quadratic inequalities. The same process again. Just a little more of a recipe that we're going to tack onto the bottom of it. Thanks for watching. Cheers. Have a good one. Bye.